This is the first part of our lectures on logarithms. So we begin with a definition. So let us consider a positive real number a. And this real number a is something has any value other than 1. This could be 1.1, it could be 1.25, 3, 4, 3.14, it could be anything. As long as it's not 1, we are fine with that. And then we're going to consider another rational number, x. Now, let's say we give an equation. If an equation is defined by this particular form, that a raised to the power of x equals to n, this is an exponential form, or you can send an exponential equation, then is there any way that we can retrieve or we can find out the value of x, that rational number? So that can be done with the help of logarithm. So if we have a raised to the power of x equals to n, then if we take the logarithm of the number n with a base of a, then the value that we obtain is x. So let me write it down with the help of an example, then it's going to make more sense. So we know, let us consider a rational number a with a value of 2. Right? Now let's say we are going to raise it to the power of 5, so that means we're going to multiply 2 to itself 5 times, and that is going to give us 32. So we know 2 raised to the power of 5 is equals to 32. Now this is known. What if we say 2 raised to the power of x is equals to 32? Now I start off with this particular equation. Is there any way to know the value of x? Yes. So what we will say here, that if we take the logarithm of the number 32 with the base 2, then what we obtain is x. Now as per this definition, we know that this is x. So what is x? So here x is 5. So it's saying the logarithm of 32 with the base 2 gives us the value of 5. This can be calculated using a scientific calculator, or even if we go to some archaic methods, so there are some tables lying around, we'll be using it later on. That is going to give us the value of x, which is equals to 5. We are going to consider a few more examples. Let's say we have 10. When we raise it to some exponent x, we get 1000. What is the value of this particular x? If we use the definition of logarithm, then this will become logarithm of this number 1000 with a base of 10, and that should give us the exponent value of x. However, this is a very simple problem. We know that if we raise 10 to the power of 3, so that is 10 multiplied to itself 3 times, that should give us 1000. So here we know that the value of x is going to be equals to 3. So we can say the logarithm of 1000 to the base of 10 gives us the value of 3. Then let's write down a few more examples. So we have 3 raised to the power of 4, so that is 3 multiplied to itself 4 times, so that should give us 81. Now if we use the definition of logarithm, so we know that logarithm of 81 to the base of 3 must give us 4. Another example will be, let's say 7 raised to the power of 0 is equals to, now anything raised to the power of 0 is going to give us 1. So if we apply the definition, that logarithm of 1 the raise to the base of 7, so that is going to give us 0. Now if you remember the definition, that this value should be always, this was a, remember, a raised to the power of x is equals to n, then we say logarithm of n to the base of a is equals to x. There we mentioned that a, the value of a must be greater than 1, so here everywhere it's a satisfy, we have 7, 3. Now what if the value of n is equals to 1? So that is going to give us 0. So regardless of what the base is, so this is a very general form, we can say logarithm of 1 is always going to be 0 regardless of what the base is going to be. So if we generalize it to a, this is always going to be equals to 0. Let us look at another example. Let's say we have 81 raised to the power of a quarter. So that should give us, so we don't know what is the value. So that value is, let's calculate it. This is we know 3 raised to the power 4 is equals to 81. Now we raise it to the exponent of 1/4 or a quarter. So that should give us 3 equals to 81, 1 raised to the power of 4. So this is equals to 3. So we can say logarithm of 3 to the base of 81. This should give us a quarter. Similarly, you can check it out. 128 raised to the power of 1/7 is equals to what? So that means logarithm of that value, whatever is obtained, to the base of 128 must give us 1/7. So we can quickly find it out. We can determine the value using the laws of exponents. We know that 2 raised to the power of 7 gives us 128. That is 2 multiplied to itself 7 times. Now, if we raise both sides to the power of 1/7, then we have 128 raised to the power of 1/7. So 2 raised to the power of 7 whole raised to the power of 1/7. That is going to give us 2. So that is 128 raised to the power of 1/7 is simply 2. So this value is 2. So that means we have logarithm of 2 to the base of 128 must give us 1/7. In these examples that we talked about just now, what we've done is we started with some exponents, some known exponents or exponents that could be easily calculated, and we defined the logarithm based on those exponents and based on the definition of logarithm. Now what we're going to do, we're going to come the other way around. We're going to write the logarithm and try to write down its exponential counterpart. So let's do that with the help of a few examples. So let us say we have log of 64 with the base of 2. What's the value of this particular logarithm? So we do not know. Let's assume that it gives us a value of x. Now if we apply the definition, then how do we write it? So we'll start with the base 2, raise it to the power of x, and that should give us 64. So this is how we rewrite in the exponential form given the logarithmic form. Now we know that 64. Now 64 is actually 2 raised to the power of 6. So that is 2 multiplied to itself 6 times. That gives us 64. So that means instead of 64 we can write 2 raised to the power of 6. The laws of exponents says that x must be equals to 6. So that means logarithm of 64 to the base of 2 must be equals to 6. Let's look at another example. Logarithm of 625 to the base of 3. Let's call it x. Then we can rewrite it in the exponential form as always start with the base. So that is 3 raised to the power of x equals to 625. So here you can do your calculations. I'm not going to do the calculation here. Okay, I made a simple mistake. So there should have been 5. The base should have been 5 instead of a 3. We can calculate with the help if it were 3, to make life simpler. We're going to simply keep it as 5 because we know that 5 raised to the power of 4 is actually 625. So that should give us x equals to 4. Then we can say the logarithm of 625 to the base of 5 is actually 4. So another example will be logarithm of 3 to the base of 9, which is equals to x. Then we start with the base, so that is going to be 9 raised to the power of x should be equals to 3. Now, how do we determine the value of x? So here we can use a little bit of exponential algebra to find out the value of x. So that's very simple. So 9 can be rewritten as 3 squared, whole raised to the power of x is equals to 3. Now we have a power raised to the power of another power, so that will become simply 2 times x is equals to 3. Now we have on the right hand side the exponent of 3 is simply 1. Now if we equate it, so that should give us twice of x equals to 1, and solving for x, we get x equals to 1 over 2. So that means logarithm of 3 to the base of 9 must give us 1 over 2. Let us look at a few more problems. So we have logarithm of 0.01 to the base of 10. So let's try to figure out the value of this particular logarithm. So we have 10 raised to the power of x equals 0.01. Now what is 0.01? That is simply 1 divided by 100. 1 over 100, so which is 1 divided by 10 squared if we write it in the exponential form. Now if we take the denominator to the numerator, so that should give us 10 raised to the power of negative 2. That means we have 10 raised to the power of x equals to 10 raised to the power of negative 2. Then we get x equals to negative 2. So that means the logarithmic value of 0.01 to the base of 10 will be negative 2. So it is possible to have negative values as well, as evident in this particular example. Now let us look at another problem. So let's say we have logarithm of 2 to the base of 16. So we need to figure out the value of this particular logarithm. So we can rewrite it in the exponential form as, so we start with the base, which is 16, raised to the power of x, and that should give us 2. So 16 is 2 multiplied to itself 4 times. So we have 2 raised to the power of 4 whole raised to the power of x equals to 2. Or we can say 2 raised to the power of 4x. The powers or the exponent simply gets multiplied, equals to 2 raised to the power of 1. So we have 4 of x equals to 1, and that should give us x equals to a quarter. So that means logarithm of 2 to the base of 16 is a quarter. Now we look at another example. We have logarithm of 25 to the base of 25. What should be the value? So let's assume it's x. We're going to rewrite it in the exponential form, so that is simply 25, which is the base raised to the power of x, is giving us 25. Now on the right hand side we have 25, the exponent. Since it's nothing is provided here, that simply means it is 1. So we can say x must be equals to 1. So we have logarithm of 25 to the base of 25 is simply equals to 1. Now this is true for any rational number greater than 1. So we have log of a to the base of a. This is also going to be equals to 1. We have log of b to the base of b. This is always going to be equals to 1. So what we're going to do is we're going to solve a couple of example problems, and that is going to help you understand how logarithm works, or we can say how the definition holds. So let's do a few example problems. So here we are provided with some logs. So let's begin with the first one. We have the log of 81 to the base of 9. So we need to find its value. So what we're going to do, we're going to assume that the value of this particular logarithm is x. Then we apply, and we're going to rename it as equation number 1. Now we're going to apply the definition. So we have the base 9 raised to the power of x, and that gives us 81. Now we know that 9 when multiplied to itself 2 times, that gives us 81. So that means 9 squared can be written in place of 81. So if we equate both sides, that should give us x equals to 2. And we can say that the logarithm of 81 to the base of 9 is equals to 2. So that's the answer. Let's go to the next problem. The second problem is we have to find out logarithm of 0.0001 with the base of 10. So let's assume that this value is equals to x. Now we have, according to definition, 10 raised to the power of x is 0.0001. And so that is 10, so the power of negative 4. Or we can, the another way to look at it is 1 divided by 10,000. So that gives us 0.0001. Now if we equate both sides, so that gives us x equals to negative 4. So that means logarithm of 0.0001 to the base of 10. So that gives us negative 4. Let's move on to the next problem. So we have the third problem. So we have logarithm of 4 to the base of square root of 2. So let's assume that this value is equals to x. Now we're going to apply the definition. So we have square root of 2 raised to the power of x is equals to 4. So square root of 2 can be written in the exponent form as 2 raised to the power of half whole raised to the power of x, and 4 can be written as 2 squared. So we have 2 raised to the power of, so we have half raised to the power of x, so the power simply gets multiplied. So we have 2 raised to the power of x over 2, that's equals to 2 square. And we're going to equate both sides, so that leaves us with x over 2 equals to 2. So we get x equals to 2 times 2, so that's 4. So we'll say that the logarithm of 4 with the base of square root of 2 simply gives us 4. So this is the answer. So let's move on to the next problem. So we have logarithm of 1 over 32 to the base of 2. So let this be equals to x, such that if we use the definition, we have 2 raised to the power of x, that will give us 1 over 32. Now 1 over 32, the 32 in the denominator is simply 2 multiplied to itself 5 times. Now we'll take the denominator to the numerator, so the exponent will change sign, so positive 5 will become negative 5. So we have 2 raised to the power of x on the left hand side, and that is equals to 2 raised to the power of negative 5. So we have x equals to negative 5. So that means the logarithm of 1 over 32 to the base of 2. So this is negative 5. So this is the end of our first lecture. We'll pick up some more problems in the next one. See you then.